Geneva Mechanism. Reason for the intermittent motion. Please draw the figure. I will roll on. Please write down. Shows a Geneva wheel having 4 slots. The crank rotates crank pin at A enters into a slot. Rotation remains stationary. There is a circular locking plate with the tank and it meets with concave surface in the Geneva wheel. During the time when the Geneva wheel held stationary, during the indexing period, the locking plate comes out of the concave surface to make the Geneva wheel unlocked and free to rotate. When the crank pin comes into engagement with a slot, then the angle AQO is equal to phi naught is given by sin phi naught is equal to R by C. angle AOQ is equal to theta naught cos theta naught is equal to r by c, where r is equal to radius of the crank and c is equal to center distance. Now c is equal to center distance. Theta naught is equal to cos inverse r by c. So phi naught is equal to 90 degree minus theta naught. So 90 degree minus cos inverse r by c. 360 by 2 phi naught is equal to n. N the number of slots. Phi naught is equal to 360 degree by 2n. Phi naught, theta naught would be equal to 90 degree minus phi naught. So 90 degree minus 360 degree by 2n. Two by n. Period of motion divided by period of rest. Two theta naught minus 360 minus 2 theta naught is equal to 180 degree 1 minus 2 by n. 360 minus 180 into 1 minus 2 by n is equal to this one. Okay. The velocity and acceleration of the Geneva wheel can be found out graphically, but analytical solution is also possible. Now you see, this is the figure. Okay. At any position, the angles of the crank wheel are theta and phi. Corresponding angular velocities omega, and this is omega in the directions. In the directions shown in the figure, we have the relations. This is rho sin phi is equal to r sin theta. Rho cos phi plus r cos theta is equal to c. So tan phi will be equal to this by this. Tan phi will be equal to r sin theta by c minus r cos theta. Differentiating with respect to time, so d phi by dt is equal to minus omega, and d theta by dt is equal to minus omega in this sign. This omega sign is this. So with respect to phi, this is this, and with respect to theta, this is this. Minus signs because theta and phi decreases with time. Now, okay. Whole square into d theta by dt. This gives the angular velocity of Geneva wheel at any angle theta made by the crank at the time of engagement, when cos theta naught is equal to r by c and omega is equal to 0. At the start of the motion, at the mid position when theta is equal to 0, then omega will be equal to omega r into c minus r by c minus r whole square is equal to omega r by c minus r. Differentiating omega, we can get angular acceleration of Geneva wheel.